This one's tricky because you have to know its highest point, VF equals 0, which leads me to VF equals VI plus GT. Final is 0. Initial is 26.8 meters per second minus 9.8. And that is multiplied by t. Aren't I solving this for time? How do you get... So you have to subtract 26.8 meters per second from both sides, and then divide by 9.8 meters per second squared, and that will equal t. And if you throw that in your calculator, you should get 2.7 seconds. Now this one, you throw a rock vertically, how long will it take to reach your hand? Sorry. This one, you have to kind of know that whatever it leaves at the same spot, it will come down at the same velocity. So, my final velocity is down, and it's negative, 26.8 meters per second. My initial is 26.8, but in the positive, so that's up. I'm going to put the minus right in there for the 9.8, that's gravity, meters per second squared, and t is the unknown there. So here's the tricky part a lot of you will miss on the math. It's 26.8, or negative, minus another 26.8, because I have to subtract this from both sides, which makes sense because you can only add or subtract like units. So I still have a negative 9.8 meters per second squared t over here. When I subtract those, I get, what do I get? 50 something, 53.6 meters per second. It's still negative, equals negative 9.8. That's an 8 meters per second squared t. And let's divide both sides by negative 9.8. Bye-bye to one side, hello to the other. And t equals, after all that, it should be double this, right? What goes up comes down, same. But with my rounding, it comes out to be 5.5 instead of 5.4 because of some rounding. All right, 3, you drop a rock off a building. How long will it take? Oh, what in the world was that? 3. This turns into, I screwed up, change in x equals VIT plus 1/2 GT squared. There's no initial velocity. And when I rearrange for t, it's square root of 2 change in x divided by 9.8, which is gravity. And if you put that in your handy dandy calculator, it's 2 multiplied by 38.4 meters divided by 9.8 meters per second squared. And I get, what do I get here? About 2.8 seconds. This equation I will give us for our test, so don't worry about that. 4, how long will it take? Well, VF minus VI, equals VI, plus AT. That's really just A equals change in V over T, right? And we said change in V is this, VF minus VI, if I would bring that to the other side. So VF minus VI over T. My final velocity is 35. My initial's 25. Guess what my change is? Yep, 10. And this is 3.4 meters per second squared. So this is 10 meters per second divided by 3.4 meters per second squared. and you should get 2.9 seconds. This one, number 5, we have a couple of velocities, initial and final, and we have a displacement, and we're looking for A. So the only one I can use is VF equals VI, VF squared equals VI squared plus 2A change in X. And if I rearrange that bad boy for A, it's going to be, it's always VF squared minus VI squared because you have to subtract those from both sides. And if it's going to be 2 change in X. So my final velocity was 35 meters per second. Square that. Minus 20 meters per second. Square that. And then it's 2 multiplied by the 150 meters. Don't forget to square these and try not to put that in your calculator at once. I see a lot of people making big mistakes trying to get it all in at once. Do what you got to do, but you need to get 2.75 meters per second squared. 6. Turn my notebook over. This is kind of the same. We have some change in velocity, so we have an initial and a final, and we have an A. I need distance. I'll go to red for this one. It's the same deal, I'm just rearranging for a different variable. This turns into, what am I trying to find, did we say? No, change in X, sorry. Change in X equals VF squared minus VI squared over 2A. Put your numbers in there. What do we have? 31 meters per second minus, whoops, squared. Slow down. Minus 24 and a half over my accelerate, 2 times my acceleration. Throw that in your calculator and you should get about 50.1 meters. Woo woo. Woo woo.